Let's look at some other things we can do with RAID management. So we'll label this section RAID management. And these are just a few things you can do. And there's a lot you can do to manage your RAID arrays. Let's just notice some features, including the ability to create RAID arrays, which we've already done for 0, 1, and 5. Assemble. This is what occurs during boot up of your system, the reassembling of your RAID arrays and presenting them in the dev tree to be mounted. So this assembles pre-existing array or multiple, depending on what's defined. Another mode is to manage devices, and you normally use this mode to fail devices, to take them offline in the event that you have encountered failure with one or more of your devices. Another mode allows you to monitor RAID arrays, can be used to email, run processes, etc. in the event of trouble with one or more of your RAID components. Another mode is miscellaneous, which allows you to perform queries, for example, on your RAID arrays, or to dump detail information about the RAID array, or to examine, which is uppercase E, individual components. So individual RAID components or partitions or disks. Each of these long options have corresponding short options, of course. So let's just look at a few things that we can do as RAID administrators with the Linux kernel. For example, we can enumerate the current layout of the RAID arrays configured on our system and made available via proc mdstat. Proc is a virtual file system maintained in memory by the kernel and contains data that pertain to your system at any particular time, such as processes that are running and so on. So let's cat the contents of proc mdstat, and it shows the various RAID volumes, including MD0, 1, and 2 that were previously defined. So you can always query proc mdstat to see which RAID arrays are present on your system. Not necessarily mounted, but available for your usage. So cat this file, and it enumerates currently available RAID arrays or RAID sets. As you can stop RAID sets, for example, for management purposes, deactivating them, taking them offline, which means they will not be in proc mdstat. You may also query your RAID devices using the query option passed to mdadmin. Now, the modes we've mentioned above, these are all modes of mdadmin. They allow you to perform these various management tasks. And let's say we want to query one or more of our RAID volumes or arrays or sets. We just simply run the query option and reference the name of the RAID entry in the dev tree. This will return information about the aggregate RAID storage as opposed to the individual items returned by the examine option. Notice it gives us a synopsis of the description or metadata of the MD0 RAID array. It's 4 gigabytes in size. It runs using RAID 0. There are 2 devices connected, no spares defined, which means mdadmin allows us to define spares like enterprise level RAID administrative volume management tools allow us to do, like volume manager, for example. So synopsis of MD0, dev MD1, and of course, let's just use our character classes 1 and 2. So you could shorten this command altogether by just querying all of the ones you know about, 0 through 2, and have it return information for you. So, indeed, MD2 is RAID 5, and MD1 is RAID 1, as defined. So the query option returns information about the array. Let's just include the fact that we reference the set of arrays. So returns information about the 3 arrays, 1 or 0 through 2. And that's mdadmin with the query option. Another option is the ability to flag one or more of your arrays read-only. Let's say you're concerned about data integrity or need to serve a volume read-only. Let's say your striped volume, which provides fast disk I/O. So publish RAID array as a read-only volume. Certainly there are tons of data out there that could fall into this category. So to effect this on an existing volume, one of our volumes, the stripe volume, devmd0, we'd first have to unmount it, flag it, and then remount it. So first we'll umount devmd0. So this unmounts the RAID array. And of course this should be performed when people are not using the system or via single user mode and then reboot the system to multi-user mode. You can always switch to single user mode by doing an init1, make the changes to the storage subsystem, and then switch to init 5 or 3. So we'll unmount, and then after we've unmounted, let's mdadmin and use the O option against devmd0 to set it as a read-only volume. So this flags in the super block the array, in this case devmd0, as read-only. And this can be quite useful for various applications. Once flagged, we remount it using mount devmd0 into its original location, RAID 0. And then of course we confirm with the appropriate commands such as mount, which will reflect accordingly. So let's march through these steps. First we'll unmount. So let's umount devmd0. That drops it. So now df should show that it's no longer mounted. However, mdadmin query will still return information about it. Then let's run our mdadmin to set the volume to read-only. You cannot set it read-only, currently at least, when the volume is online. So this will set it to be read-only, and there's always the verbose option which can be enabled to provide some more chatter, but it's already set to read-only, so nothing else for us to do at this particular point. And the converse of this is the W option, write mode. So you can turn it on with write, or W that is, not to, wrong key. That sets it to write mode, and this sets it to read-only mode. Verbose does nothing in that particular case. So now that it's in read-only mode, we should remount it, devmd0, and then test it. So let's mount devmd0 on RAID 0, and notice immediately mount has returned that MD0 is write protected and is read-only accessible, which means if we use mount, we should see RO as opposed to read write. That means if we attempt to, well, first enumerate content in RAID 0, we should see whatever is there. That means we can cat the contents of 100k.txt, but we may not write new data to the file. Let's try to sequence 100,000 again as a new file in RAID 0 100k.txt2, and indeed it's a read-only file system. It doesn't allow us to do so. So if there are data that you'd like to publish to a large or even small audience on a read-only basis, but benefit from, let's say, the performance enhancements of RAID, then, and as well as redundancy enhancements provided by 5 and the other levels like 1 or 10 or 6, then flag the particular device as read-only. Now supposing you'd like to return it to read-write, it's the reverse that is carried out. So now publish RAID array as a read-write, which is the original configuration, volume. So it's the same, but when we get to the stage where we flag with the O option, we flag this time with the W option to indicate that the volume is to be made writable. So umount mdadmin with the W option, mount, confirm with mount, and this of course will flag it instead of read-write, read-only, read-write. Let's save the changes and walk through the steps. So first and foremost, umount dev md0. It's gone. Now that it's gone, we need to flag it. So mdadmin, write option against dev md0 sets it to write only, or read-write, that is. Once that's set, we can always query it, by the way, using mdadmin query dev md, and in this case it's just md0. And let's just double check, we're missing a hyphen here for this long option, and indeed it is still available. Now that we've flagged it read-write with the W option, we should remount it. So let's mount dev md0 on RAID 0, echo the exit status. Notice no message to warn us that the volume will be mounted read-only this time, which means mount should reflect that it's a read-write volume. So that's one thing you may want to do, let's say, for various reasons. Just publish temporarily or even permanently your information read-only, but protected with RAID so that you can benefit from, again, the performance enhancements and redundancy features supplied by RAID. Now, what else is of interest to us? There are times, for example, where you may want to stop a RAID volume. That's equivalent to deactivating the volume, removing its dev tree entry. So, stop RAID volume for management purposes. Could be that you're experiencing problems with the array and perhaps data corruption problems due to one or more failed physical disks, or perhaps just performance problems. Maybe the array isn't performing as quickly for your database application as you envisioned. So in that case, it may be worth it to avoid data corruption to stop the RAID volume or RAID set or array altogether using mdadmin. This is where we enter mdadmin's manage mode. You can specify stop without the manage option. It is a manage mode. You can just indicate stop followed by the location in the tree. So supposing we wanted to stop dev md0, this would stop the RAID array, and it facilitates, let's just note, offline management. Now currently dev md0 is mounted. So what is the impact if we try to stop a device that's currently mounted? Well, let's go ahead and try to stop it, and notice that it has failed to stop because it's busy, which makes sense because this behavior will avoid data corruption by causing us to properly stop the volume after having unmounted it. So again, if we execute mount, you should see that it still exists. With that said, let's umount dev md0. That drops the volume, which means mount should no longer reflect it. Now let's use mdadmin to stop. Now before we stop it, let's just take a quick look at the dev tree. And if we tab things out, notice that MDs 0, 1, and 2 are there. So the device is still available so that we can reassemble it rather quickly after, or remount it currently, that is. But after we've stopped it, we'll have to reassemble it, meaning we'll need to point to the appropriate partitions which are part and parcel of devmd0. In other words, we'll have to reassemble the array in order for the dev tree entry to be created. Across a normal reboot, no big deal. The array isn't deactivated. The notion is that arrays should continue to run indefinitely until they crash. So the fact that you've had to deactivate it probably reeks of some sort of problem with the array? Well, there possibly could be, such as hard drive spindle errors and so on. So with that said, let's go ahead and stop the device in the manage mode. And when you stop the device, it removes the entry from dev, which means you can't just remount it on the fly. So let's just note, stopping or deactivating the array will remove its /dev md entry. In this case, /dev/md0 has been removed, which means we can't simply remount it. And in fact, if you try, it will fail because the file doesn't exist. Let's try this out. RAID 0, and it's definitely not there, so we can't mount it. So in order to remount it, we need to reassemble it. And there are ways of doing it. There's an easy way using the scan option, and there is another way if you know the devices that constitute the RAID array. You can specify on the command line to reassemble it with those particular items. And there's another way. You can also specify the component parts in the mdadmin configuration file, which is located in etc. So you can place the instructions here, which is highly suggested that as you create RAID arrays, that you place an array statement in this file which associates a particular array such as devmd0 with a set of partitions. So let's just note there are multiple ways to reassemble RAID arrays, including but not limited to 1. Command line or CLI. So for example, in our case, we could execute mdadmin with the assemble option, which is one of its modes. So we've looked at miscellaneous in the query option, assemble, as well as manage to stop the device. 3 of the important modes. So we'll assemble devmd2. That's a device that will be created out of dev, or this is a devmd0, that is out of dev sdb, and this should begin at 5, and dev sdc 5. So this command reassembles on the command line devmd2. So let's just note restarts or reassembles devmd0 from its component parts, which can be specified in mdadmin.conf. Let's do this and then stop it altogether. We'll mount it to be sure the data are correct. So mdadmin, assemble mode, md0, pull together sdb5, sdc5, and notice that md0 has been started with 2 drives. That means in the dev tree we should now find md0, which means we may mount devmd0 in its rightful location, and that means the mount command will show it, and that also means if we take a look at the directory we should see our 100k.txt indeed. So let's restop the device. History grep mdadmin grep stop, and then we'll use 751 for example in manage mode to stop md0, which will remove its entry. Now it's mounted, so of course we have to umount it using either the mount point or the dev tree location, and then stop it. So now it's stopped, which means dev md0 is gone. So with that said, and of course that means if we run a query against dev md, let's say 0 through 2, 0 will not return, but 1 and 2 will. So that's one way to reassemble from the command line if you've memorized the component parts. But of course this will invariably slip your memory over time as your Linux system performs optimally, and as a consequence will seldom present a failure opportunity. So it is rare, Another way is via the etc mdadmin.conf file. This configuration file allows us to associate devices and arrays. So associates devices and arrays and management/notification info, such as who to email if the monitor mode has been entered and the MDAdmin tool has encountered problems, and so on. Now, the syntax is rather straightforward. We'll include two lines. One will be a device line which outlines all of the disks that MDAdmin should scan in search of superblock information which contains RAID arrays. In other words, which of the partitions are most important on this system, since we could have dozens of which a subset may be RAID, or not. But in this case, since we're dealing with RAID, we assume that a subset of the partitions are RAID. So we can use character classes here. So we want MDAdmin to scan dev SDB partitions 5, 6, 7, and 8, or 5 through 8, as well as dev SDC 5, 6, 7, 8. So these are partitions that contain RAID information. And more specifically, here is a description of an array that can be assembled via this config file. Its location in the dev tree when reconstructed will be dev MD2, or MD0 that is. I keep referencing 2, which is currently mounted. And it will be reconstructed using the following devices. This is just another way of specifying what we've specified on the command line. Dev SDB, let's go with, in this case for the first one it's just dev SDB 5 and dev SDC 5. This is a step that you should perform slightly after settling on a production RAID configuration if you use kernel-based RAID as opposed to hardware-based RAID, although the suggestion generally is that you use hardware-based RAID over operating system-based RAID. So let's modify mdadmin.conf, and here we see some mail information and auto assemble and so on. Let's paste our device and let's get the array setting for dev MD0. And once this works for MD0, then you can present your information for the other two arrays. Let's paste this in. So here's our array directive, which will instruct MDAdmin to construct dev MD0 out of these devices. Be sure to specify the appropriate devices, although MDAdmin is smart enough to check whether or not the components belong to the same RAID set because the superblock contains that appropriate information. So now MDAdmin contains that information, and we can attempt to reassemble using the mdadmin command dev MD2. So currently in the dev tree we have 1 and 2, not 0. And if we scan, we'll see that 1 is, or 0 is not available, 1 and 2 are. MDAdmin with an assemble option will attempt to scan the configuration file if we specify the appropriate device, MD2 or MD0, and notice it's been started with 2 drives. Let's confirm it using MDAdmin with the query option. And there, 0 has been put back into place, which means in the dev tree we should see MD0. And that's because MDAdmin, when given the assemble option, read the contents of the mdadmin config file in etc. So it's put it back together. That means we can mount it in its rightful place, RAID 0, followed by an LSL RAID 0. And indeed, it's back into the appropriate configuration. So after stopping or deactivating a device, you need to reassemble it either manually on the command line or via the configuration file, which you will have configured, of course, shortly after successfully setting up a RAID environment. There are a number of settings and options, myriad settings and options that you may evoke. For example, monitor mode, which allows you to run a process and even demonize it, to have it monitor for problems and email you in the event of some sort of catastrophe or a catastrophe waiting to happen if it's able to detect it. MDAdmin is a full-featured interface, albeit text with numerous commands, but it provides enterprise-wide configuration of RAID devices, allowing you to add hot spares, for example, or to fail devices in the event that you need to. For example, in management mode, you can fail a device or stop the device, as we've done, to take it offline. Miscellaneous mode allows you to get detail, like we looked at the query mode. Let's just show you, for example, MDAdmin, upper D or lower full word detail against a particular RAID item, gives you information about that RAID item. This is the superblock information that's present, which associates a given array with certain disks. So this is how MDAdmin knows that devMD0 consists of dev SDB5 and dev SDC5, and is able to reconstruct it accordingly. And the dev device is assigned a unique ID, which can be referenced wherever UUIDs are accepted. It also includes whether or not it's clean, when it was last updated, the size of the array, and the level of the array. And this can be consulted for all of your arrays, for example 0 through 2. I'll just dump them accordingly. This one we know is the RAID 5 array, MD2, and it tells us here that it's RAID 5 6 gigs. And as we scroll down, and of course to manage this RAID array, it sacrifices the equivalent of one of its disks, or 2 gigabytes. So really, in the RAID 5 set are 8 gigabytes, but only 6 or 3/4 are available. As we scroll down, we see when it was last updated, the fact that it's clean, the chunk size, which defaults to 512, which can be adjusted depending on your configuration, any events associated with it, its UUID, and most importantly, the devices that are associated with this particular array. So even if you forgot what you did initially to set up the RAID array, shortly thereafter, as long as the system's up and your RAID devices have not been deactivated, you can always query with the detail option the device as it exists in the dev tree, and you'll get this sort of enumeration. So partitions 7 and 8 from both disks belong to this RAID 5 array. And as we scroll up, we also see information for MD1, the fact that it's RAID 1, so it's a mirror. 2 devices, and its size and its use dev size, meaning the size that's used to keep track of the mirror data. Notice that both are exactly the same, as they should be, with a slight tolerance for a variation of up to 1%. And these are the 2 devices that constitute the mirror, dev SDB6 and dev SDC6. And that just gives you details about the RAID array using the D option, for example. Let's just note 6 other options. So MDAdmin D, dev MD, and we'll just place between here 0 through 2, close right bracket, enumerates info about arrays, whereas MDAdmin with the examine option, that's the E option, will give us information about the components. So for example, we know that, let's take a look at this RAID 5 device. 7 and 8 from both drives belong to this RAID 5 device. So MDAdmin E, or examine, dev SDB7, for example, tells us information specifically about SDB7, including, of course, but not limited to, its size, the number of devices in the overall RAID set, the type of RAID set that it belongs to, when it was created, the UUID of the array, the device's distinct UUID, that's the partition itself, and other useful information, whether or not it's active, which means it's online, and so on. And you can do this for any of the devices or all using the appropriate character classes. So for example, SDBC and 7.8 will focus on just those partitions and enumerate them accordingly. That's the examine option, which gives you more information about the disk and not in particular the RAID array. So that would be dev SD character class BC, and character class 7.8 enumerates info about the 4 partitions on the 2 drives. Of course, dev SDB and C. So the E option is another option that's available to you, and there are again myriad other options available to interrogate your RAID arrays. So these are just some of the features, and we'll be moving on to some other topics to give you a sense. We just wanted to show you how to set up RAID to do some basic administration, and from there you can just look up the other options to see how to apply the other settings.